Here's an example. So let's say that these are IQ scores for the class. All right. And you can see that kind of consistent with what we think is going on in the population anyways. We believe that in the population, the average IQ is right around 100. And again, this distribution of IQ in your class kind of reflects that. Most people in your class have an IQ right around 100. Some, are below that. Some, well, I kind of doubt that these people would be in your stats class. You never know, but usually people with an IQ between 55 and 70 are not going to be able to handle a university level statistics class. And then, these are people in your class with IQs above the mean, all right, above 100. And then there's you. Okay? All right. Now, if we were to take everybody's raw score in the class and convert it to Z, so we're going to take everybody here who has a mean of 100, convert it to Z. Same thing. Everybody who has an IQ of 115, we're going to convert that to Z. Every single score in this class gets converted. What will the Z-score distribution look like? The suspense is killing you, right? It's going to look exactly the same, except the scores on the x-axis are going to change, right? These are raw scores that we plotted here, and down here we're plotting Z-scores, all right? Now, frequency is here, but I just don't know what the actual numbers are, so I didn't put in that y-axis. But if you look at how many people have a raw score of 55. Look how many people have a raw score of -3. Consider this. The number of people who have a IQ of 70, raw score of 70, have the same number of people have a Z-score of -2. Right? So the shape, if you were, well, I guarantee you it's the exact same shape because all I did was copy paste. All right? So these two distributions are identical, the raw score and the Z-score. The only difference is what's plotted along the x-axis. Here we have Z-scores and up here we have raw scores. All right? Now you might be asking yourself, well, why is it? How come this has happened? Why is this the way it is? And I'm going to explain. First of all, remember that the mean of any raw score distribution becomes 0 on Z. Now, why is that? Well, remember I said that when you standardize all these raw scores, you recalibrate. And part of that recalibration means that whatever the mean is up here, it will recalibrate to 0 down here. Okay, so if this mean up here was 162, then that 162 becomes 0. If this was -16, so not an IQ, but -16, the -16 becomes 0 down here. Okay, that is true 100% of the time. Pinky promise. Now, so that's an important thing to remember, that the mean of the sample, in this case 100, becomes 0 on Z. If we were working with a population, the mean of the population, whatever that mean happens to be, it also gets recalibrated to 0. All right, so whether we're talking about a sample mean or a population mean, it becomes 0 on Z. Now, you might be asking, why does this 115 become 1? Why does this 130 become 2? Why does this 55 become -3? Right? So that's a good question, and I'm going to show you why. And we're going to do this without even using a formula. A lot of people, they rely on formulas and they can plug numbers in, but they don't understand why things are the way they are. They just know how to use a formula. Well, I'm going to show you that formulas, we can use formulas, but they can become crutches. They prevent us from truly understanding what's going on. So I'm going to explain this to you without using a formula. All right. So here is the answer. All right, what you need to know is that whatever your standard deviation was in your original raw score distribution, that standard deviation now becomes 1 unit on Z, the equivalent of 1 unit on Z. All right, now, I know that doesn't make much sense yet, so just hold on, okay? I'm going to explain it. So these are Z scores, right? So 0, when you go to a Z score of 1, how far have you jumped? Well, you've jumped 1 standard deviation unit on Z. Similarly, when you go from 1 to 2, you've moved another standard deviation unit on Z. All right, when we look at 3, how many units, standard deviation units above Z are you? Well, you're 3. Here, you would be 2 units below Z, 3 units below Z. Now, that's in Z scores, right? The Z distribution uses standard deviation units. But what does 1 standard deviation unit equal in raw scores? In raw scores, it's whatever your standard deviation was. So let's pretend in the case of IQ, and this is actually what we think it is, hypothetically, we think that the mean IQ in the population is 100 and the standard deviation is 15. I'm just working with a sample though. So standard deviation of the sample is 15. Remember that the mean for the IQ is 100. All right, so 15, your standard deviation, now is represented by a standard deviation unit on Z. So 1 standard deviation unit on Z is the equivalent of 15 raw scores in the sample. All right, so let's look at this. Here are your raw scores down here, right? So here's your mean 100. Now, if I were to jump 1, because 100 becomes 0, here's your mean on Z, and if I were to jump 1 unit, now I have a Z score of 1. How far have I moved in raw scores? Remember the rule? 1 standard deviation unit is whatever S is in your sample or population, but I'm working with a sample here. So it's 15 raw units, raw score units. So this 1 standard deviation unit is worth 15 raw scores. This one is another 15 raw scores and another 15. Each one of these units is 15 raw scores. So if we start at 0, which is 100 in raw scores, right? 0 becomes 100. If I move 1, that means I've moved 15 raw scores, right? But it's 15 raw scores above the mean. So 1 is the equivalent of an IQ of 115 because I just added 15. If I move 1 here, I'm moving 15 down here. So what about moving from 1 to 2? Well, 1, remember I've jumped 15 from the original raw score mean. So here it's 100, I've jumped 15. All right, and if I jump another 15 from 1 to 2, that's another 1 standard deviation unit. Now I'm at 130. So you see how you're just going plus 15, plus 15, plus 15, and then down here it'd be minus 15, minus 15, minus 15. And you're able to do that without a formula. Well, I gave you easy numbers to work with, okay? So that's we got to take that into consideration. But you now are able to do this because, or as long as, you remember that 1 unit on Z, so 1 standard deviation unit, is the equivalent of whatever the standard deviation is in your original raw score distribution. I'm going to test you on this, going through the slides here, okay? So we'll make sure that you understand it.